I'm going to talk to you a little bit about the unit circle again and some of the key coordinates that you should remember or you should learn, and this is going to help us really when we tackle looking at solving trig equations without the calculator. Okay, right, if you recall some of the trig ratios we discussed when we looked at the right angle isosceles triangle where we had sides of 1 and this side was root 2, and we had angles which were pi over 4 or 45 degrees in the corners, right? Now if I take this triangle and I scale it down, so I make the hypotenuse a length of 1, okay? So if I scale it down, let me draw that again because that was terrible. Okay, so if I scale it down like this, okay, and I make this side 1, okay, I'd have to divide each side by root 2. Okay, so root 2 divided by root 2 is 1, and then this side would be 1 over root 2, and this side will also be 1 over root 2. Okay, but the angles don't change. If you scale a triangle down, then the angles don't change. So this would still be pi over 4, and this would still be pi over 4. Okay, now if we go to the unit circle, these 4 coordinates here, okay, are located from this triangle. Okay, these values, if you look at it, you got 1 over root 2 everywhere. So it's made from this triangle, and how it works is this. Okay, remember this is a right angle with the y-axis and the x-axis, and if I chop it in half, I get pi over 4, right? Okay, or 45 degrees, which is pi over 4. Okay, but if you have a look, this triangle, okay, this triangle here, let me do it in sort of a bluish colour here. This triangle, okay, is a unit circle, so that means that this side's 1. Okay, there's your 90, and that will also be pi over 4. But look, it's this triangle just back to front. So if you want to find this coordinate, we just need to look at the sides of this triangle, right? We would go from the origin, we go along this length, okay, and then up the same amount. So we'd go along 1 over root 2 and up 1 over root 2. So this coordinate here is 1 over root 2 across and 1 over root 2 up. Okay, let's look at this coordinate here. Same principle, using the same triangle. Okay, using the same triangle, I'll do it in a different colour. Okay, there's the triangle. Okay, there's the right angle triangle there, and there's your 90, there's your 1, that will be pi over 4. Again, chopping that 90 degrees in half, that's pi over 4. Okay, and then the same triangle again, I'd go along 1 over root 2 and up 1 over root 2, but the coordinate would be, to get to this point here, would be minus 1 over root 2 and then up 1 over root 2. Okay, and then using the same triangle, but down here, I'd go minus 1 over root 2 across, and then minus 1 over root 2 down. So there you go, to get to that coordinate. And then the same triangle used 4th time to make this coordinate, going along 1 over root 2 and then down minus 1 over root 2. So I've made these 4 coordinates just from this triangle alone. Okay, now but let's look at angles to do with this. Okay, so let's look at angles now. Right, let's take this coordinate. Now if you recall in the unit circle, remember if we have an angle like this angle theta, the x component of the coordinate made by going up that line is cos of the angle, and then the y component is sine of the angle, right? Okay, so but what is this angle to get to this particular spot? Well, the angle is that, it's pi over 4. So what we've just worked out is that cos pi over 4, well we knew this already, cos pi over 4, or cos of 45, is 1 over root 2, and sine of pi over 4 is 1 over root 2. Okay, that coordinate there. But if we carry along, if we keep going along, each one of these little sections here, that's 45, that's pi over 4, this is pi over 4, this is pi over 4, this one, this one, this one, this one, this one. Each one of these little sections is worth pi over 4. So if we look at maybe, I don't know, let's pick a random coordinate, let's pick this coordinate here, okay? And what we do is, from the origin, so from the x-axis going in anti-clockwise direction, we went around like this. So what is that large angle there? Okay, well let's just count the little sections. 1, 2, 3, 4, 5. That's 5 pi over 4, 5 lots of pi over 4. But if you take the cosine of that, that will give you the x component here. It would be minus 1 over root 2. And if you took the sine of the same angle, okay, that large angle, it will give you the y component. Yeah, the y component would be minus 1 over root 2. Okay, so this circle is going to help us a lot. So when we were looking at maybe working out the cosine of something, or the sine of something, the sine of something, or even working backwards. So for example, someone said to you that cosine of something, some angle equals, let's say, minus 1 over root 2. Okay, and say work it out without a calculator. If you knew this circle and you remembered this trick with this circle and these particular coordinates, you can easily work out what that angle is, because we're looking for x components where we have minus 1 over root 2. Okay, we're looking for an angle where we do the cos of it equals minus 1 over root 2, but remember that relates to the x component. So where do we have that scenario? Well, here you can see the x components from minus 1 over root 2, and same here. So we're looking at this coordinate and this coordinate now, starting from the origin. This is one potential answer, so theta could equal that large angle. Well, what is that angle? 1, 2, 3. Okay, that's 3 pi over 4. Okay, or it could equal this large angle to get to this particular spot. So it's 1, 2, 3 to get there, 4, 5. So theta could equal 5 lots of pi over 4. Okay, neither one of these fractions simplify. But if you check it out, okay, we'll do that now actually. We'll check it out now. Cos of 3 pi over 4, what does that come to? And then let's just double check that equals minus 1 over root 2. Let's just figure that out, right? So go to, let me clear all this stuff out. Go to cos, and we want to do, what was it? Was it 3 pi over 4? I think, no, hang on, what was it again? 3 pi over 4, yeah. So 3 pi, are we working in radians first of all? Yes, we are. Okay, if you're not working in radians, click that, go to document settings and check that that's in radians. Okay, 3 pi over 4. Press enter, we get that. Now what is 1 over root, what's minus 1 over root 2? So let's see if we get the same decimal. Minus 1 over root 2. We get the same number, so it works. So there you go. So that definitely does equal minus 1 over root 2. Okay, and you can work out lots of things like that. Okay, so knowing this triangle is knowing this circle and knowing how it relates to this triangle is important. Okay, so I suggest you spend some time maybe learning this. Okay, we're going to look at another circle like this made from the second triangle we discussed earlier. Okay.